to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, my name is Leonard Facchinetti, and let's write some code together, shall we? What we have on the menu today is a series of things. The end goal is to return to our waveform display. If you are new here, we are working on real-time audio effects for REAPER, and we are focusing on the display capabilities, on the user interface of the audio plugins. To help you see what's going on with the audio, it's particularly helpful for beginners, but I think it's good for everyone working with audio to see what's going on. So we want to return to the waveform display, so we want to do the contours of the waveforms. And we have to do some things before we can get there. We will have to look at the Bézier curves and how to do the Bézier drawing, something that we have done in the past, but since we did that, we restructured the library that we are working on. So some things have changed and we need support from the old library, the implementation of Bézier curves, into the new library. But there is yet another thing that I want to do before I get to that. So we want to do the contours, but before we have to do the Bézier curves. But before I do that, there is this new thing that came in some update. I don't know which one. And it is a kind of annoying particularity of JS effects, and I want to investigate that real quick to see if we need to change some things about the way we are naming variables and functions. So let me show you what the problem is. It actually came up in a previous stream, so you may be familiar with this already. So let's open the waveform display as it currently exists, and if I enable this for now it's plotting my microphone, so you can see what the waveform looks like right now. And let's go to the source code for this here in the IDE that comes with REAPER. Oh, hello, Bo. Yes, there will be a bit more of Bézier curves. So it will be mostly just cutting and pasting and making sure that everything works and is named correctly, so that we can use this for drawing the contours. And when I say contours, I mean we are drawing the shape of the waveform, the solid blob that you see as the waveform. And it would be nice to draw the edges here. And in a previous implementation of this, I kind of hacked this together by having one line. But I think it would be nice to have multiple thicknesses of the contour if necessary. So we are going to do that with very simple Bézier curves, as you're going to see. They are going to be linear Bézier curves. So there's just going to be lines, but they're going to be thicker lines. We'll get to that. Let's investigate the other issue first. The other issue is we named everything in our library with an underscore. The first letter is always an underscore. It's actually a namespace. It's underscore dot. Oh, and Andres is here. Hello. It's great to see you here again. So the issue is, or the reason why I named everything starting with an underscore in the first place was so that it would sort here on this right pane when you are investigating issues in the IDE for JSFX that comes with Reaper. It's handy to have all the variables in the library grouped together and below your own variables. There is no notion of sorting. There is no notion of moving things around. This is a very simple view. It is a table with 3 columns. It is the number of references for a particular variable, the value that that variable holds in the at the moment, and the name of the variable. And it used to be the case that underscore sorted last. What that meant was that all our variables from the library would be last. But now, this changed. I don't know when, maybe in the last couple releases. This sorting is now putting our variables, the library variables, above. It's still sorting everything alphabetically, as you can see. A, B, C, and so on. We are not defining our variables alphabetically. So this is not the order of definition. This is being sorted alphabetically. It just so happens that for whatever reason, underscore used to be the last character. Now it is the first. So what I wanted to... it's not the end of the world. It's no huge deal, but I wanted to give this like a couple minutes to see if I could sort this out. See what I did there? Sort this out. Because these are the variables that we as the programmers using the library would care about, because these are the variables that we have defined. So this is a plugin using the library, and in our plugin we have these variables like waveforms. So we care about this variable, and it would be nice if this showed up first. If it shows up last, it's not the end of the world. But let's see if we can make it show up first. And I'll just check if there is like no other changes that stand out here on this pane. But no, yeah, everything is as it used to be except for the ordering. Maybe we could ask on the Reaper forum, or maybe someone has already asked on the Reaper forum why this has changed. But let's just investigate the ordering of the variables here on this right pane. That's what we are going to do. It's not terribly difficult or terribly challenging. It's just a nice thing. It's not even terribly important, but it's a nice usability kind of thing for the library. So I'll call this letter or variable ordering. I don't know why I capitalized the name. I just did. Okay, so if I have a variable like hello and hi, and if I have a variable called z at the end, or maybe z in the beginning, this proves the point that the order here has nothing to do with the order of assignment. Now, if I have underscore dot something, previously that would be the last variable, but now it's the first. If I put 2 underscores, it's the same. If I put underscore something, it's the same. And if I have capital letters, they sort along with the letters, or do they sort less? Because if you're doing sorting using the primitive C sorting thing, I think it's going to sort all the capital letters after everything else. So to prove my point, I can have a letter A here, maybe ABC. And if you're using the, I guess, the standard library in C, I think that capital letters sort first. So we would see A here at the top. No, yeah, I think that this is just going to sort alphabetically, but in case insensitively. So using capital letters is not going to help. Using a dot in the beginning is not allowed. Oh, it is allowed. Is this right? Oh, I named the variable the same thing. Oh yeah, it's a syntax error. It's not allowed. So a dot in the beginning is not allowed. What else could we try? Well, I guess the only other option is for us to maybe prefix our variables with something like this. Because then we have a good chance of sourcing last. But then you would see these ZZs all over the library, or all over your code when using the library. And you would also see it on the source code for the library, which is not super nice. And I believe that letters and underscores are the only characters that are valid in variable names, because everything else sort of has a meaning. So if I do this, this is modulo. That's a syntax error. This, okay. Oh, but this is not, it's not the variable name. And I'm going to test something, but I don't think it will be nice to do this. But is Unicode allowed in the middle of variable names? Well, probably not, because it doesn't even show up here correctly. Oh, but hang on, it is. It is doing something. It's not a. This is a proper JS effects. It's a valid plugin. It is ignoring the poop emoji. Oh, and it's sort of rendering the poop over here. That's so cool. It's rendering the poop in red, and then it's ignoring the Z. Well, it's ignoring one of the characters. Okay, it's ignoring this, and then it's ignoring all of that too. So this variable exists, and then the rest of the line is discarded. Yikes. We could try other characters like this, but I don't think it's going to work out very well. Yeah, still the same thing. And then dollar signs or at signs, they start sections. Hashes, they have special meaning. They are strings. Dollar signs are constants like pi. You cannot just have any other naming there. There is pi, there is E, the Euler number, but you cannot make your own. This is modulo, as I mentioned. This is exponentiation. This is and this is bitwise and. This is multiplication. Then we have the underscore, maybe backticks, but that's a long shot. And I exhausted the keyboard. So it seems like the only viable approach would be to have, instead of the underscores in our library, we could have ZZ. And then our library would have variable sourcing last. Oh, there. Hello, Tail. Nice to have you here. And there's also Fee. And maybe there are others, or are these the only three? Because I don't know of others. I don't think they're documented. I don't remember seeing them in the documentation. So I guess this would be the only way of going about this. So I think that the ZZ is just, it's no good. I think that the underscore is okay. At least all our variables are packed together. All the library variables appear, I guess, first now. And then you would have a section of our library variables, then the user variables, then the system variables, and then some statistics. So yeah, small ergonomic hurdle, kind of bad, but okay. So let's move on to the Bézier curves and what we'll do to port them to the new library. Hopefully it will be just a cut and paste, but let's revisit the old implementation. So this is the section about Bézier curves. I think that there may be tests for this. No. Well, let's see. What are all the places where this is called? Yeah, this is just a demonstration. So there are no tests for this. So it should be fair to just cut and paste this section and it should work. Let's see. Where do I want to have this? Probably somewhere near where we are doing other drawing things. I guess the rounded rectangle fuse situation could be a good companion for this. I'll do it here. Okay, so let's revisit this implementation and see what we did in the past and what needs to change. Hopefully very little. So first of all, we have this magic constant here that we calibrated by hand. It has to do with the drawing that we do. We want the whole point of me bringing the Bézier implementation back here to the new library is that I want to draw lines that are thicker. In JSFX, you can only draw lines 1 pixel. The stroke of the line is 1 pixel. The width of the line is 1 pixel. And I want to be able to draw lines of arbitrary thicknesses. So the way I do that is by computing each point in the line. So given the start and end points, I compute each point in the middle and I draw a small square. It's like a pixel in that position. And we have this constant here that tells us how many squares to draw. So we know the path from origin to destination. How many squares do we need to draw? The bigger this number, I think that the more squares we draw, and the smaller the number, the fewer squares we draw. And of course, the more squares you draw, the smoother the curve may look, but you are doing more drawing. So it is potentially slower. And we calibrated this number by hand so that it looks okay, even with very curvy curves, if you know what I mean. So even if the curve is, well, not a straight line, but very curvy, it still gives us enough points on the path for it to look good. Or at least it did back then. Maybe we'll have to change this. And then this is the implementation of the formula for a Bézier line. It is essentially just linear interpolation. It's not the end of the world. And we picked this up from the Wikipedia article cited here. And then there is also this other source here. I don't remember exactly where, I don't remember exactly what we got from here, but I guess it was this idea of these steps came from here. Then everything in here seems okay. I'm now following the convention of putting the local variables on a new line. So the way that this works is we'll need to do an iteration, we need to do a loop, and we need to know how many steps to take. So we use that magic constant, and we look at the Euclidean distance. Okay, I'm not sure if we ported the Euclidean distance already. Oh, we did. Great. So just compute the Euclidean distance between the two endpoints. Then we put our cursor there, and we increment time, and we loop, and we draw a line. Oh, so yeah, there is some work for us to do here, because our Bézier drawing is not taking in account the thickness of the line. And it's not also not taking into account the color, but I think that the color you can just set before you call the drawing. Because that's how you usually do drawing in JSFX. And there is this, I keep coming back to this, because the issue I have is I don't really like how you have to set the color and set the position and then call the drawing primitive. In many cases, I think it makes sense to pass the color as an argument to the drawing primitive. For instance, in the waveform display, you pass the colors as arguments because there are multiple colors. There is one color for the stroke, and there is one color for the cursor, and there is one color for the field, the body of the waveform. So in that case, I could not receive colors as global variables or set colors before I call the drawing function. I have to receive colors as arguments. But then there are places like this, and this is closer to the drawing capability that comes with JSFX. And to use that, you have to set the color first and then call it. So that's why I keep going back and forth. I think I'm just going to receive the color, the opacity. Oh, the opacity is not going to work fine. For the opacity to work, I would need to do off-screen drawing and then bleeding. There are previous streams in which I cover this. It gets quite tricky, so I guess I would just receive the color and I guess the stroke width. And that's what I will do. Okay, so we need to change this here. Right before I start drawing, I will switch to the right color. And this is how I switch to the right color. Yes, it is. And then instead of doing this, this implementation, as you can see, is kind of silly because we are drawing a line, but then we were doing this in increments. But of course, all the increments would be collinear. So this is just because it resembles the other implementations of like the quadratic and cubic Bézier curves in which the points will not be collinear. But in this case, it's kind of a silly implementation. But it pays off because now that we are doing the stroke width, we will change this and we'll change all the other ones similarly. So what we have to do is, well, hang on. Oh, okay, there is the time. Time is varying. So I guess what I want to do, how does this even work? Oh, I calculate the X and Y position separately. Okay, that makes sense now. So I guess what I need to do is GFX, what is it, fill rect? No, it's rect. Fill? Or is it just rect? Man, I don't really like how people abbreviate things, because then I have to remember not only the name of the thing, but also the abbreviation that they decided to use. It's rect, and it receives X, Y, width, and height. Okay, so X and Y will be these coordinates. Width and height will be the stroke width. Okay, so with that out of the way, I'm going to comment everything else that has to do with the Bézier drawing. I will comment all of this out. I will go to my waveform and I will try to draw thicker lines. So right after I draw the waveform, I will try to draw from, let's say, 20, 20 to 200, 300 on some green, 500, and I stroke width of 4. Now let's do the song and dance. Okay. Rex needs 4 parameters. Well, I thought I gave it 4 parameters. 1, 2, 3. Oh, okay. Now it has 4 parameters. Okay, and as we see here, that constant we had is not good enough. This is not a smooth line. So now we need to play around with that constant. I will put my code over here, and I will put my plugin here over my head. Let's go into the library, or perhaps not. Yeah, perhaps let's not go into the library. Let's just find in the library where that magic number is. And then on the init block, we can reset that number. If the number is 1, then this should be as smooth as we can make it. Let's bring this number down until it doesn't look very nice. And the waveform is kind of glitching. I don't know if you see this on the stream. You probably do. Maybe even my voice is glitching. This whole thing is falling apart. So I guess I will turn off the waveform drawing for a moment. Okay, this should improve things in terms of performance, maybe, hopefully, we'll see. So if the multiplier is 1, then we have a lot of points. It's very smooth. If the multiplier is small, we get only a few points. That's bad. 0.1 is not enough. 0.2, oh, 0.2 is okay. 0.5, 0.5 is nice. 0.3. It's not perfect. You can see the aliasing. And when I say aliasing in this context, I don't mean aliasing as in audio, but I mean aliasing as in drawing. You can see it as a kind of a jagged line. Let's see if increasing this makes it any better. Well, it is a bit better, but not by a lot. And the performance hit is a big deal, I guess. We are not even getting 30 frames per second here, and even the quality of the stream may have decreased. So yeah, let's also look at the number of frames per second here to see if that is impacted. Yeah, this is not a good frame rate. If I... Not even that is holding 30 frames per second. That's not good. Well, perhaps we should be implementing this differently. the way we are implementing this right now, oh boy. Remember how I said this was going to be a cut and paste? Well, it's not going to be a cut and paste. It's going to be freaking complicated because it always is. I think that the issue with the performance here is that I'm always computing the position of the points. So each one of these squares is a point. I'm always computing the position of the point using the whole formula for Bézier interpolation. And we have to do multiplications and additions and subtractions over and over, and even a function calls over and over. And that cannot be fast. What if instead I just computed P0 and then this increment, and then on each one of these steps, I incremented by this amount. Then I would be reducing the number of multiplications and additions and everything. Yeah, I'll take note of this. I was really expecting that this was going to be fast enough because we are in the GFX block, but the GFX block cannot hold a frame rate. We'll have to improve the performance of this. We'll have to optimize this. Hopefully, when we put this to actual use in the waveform display, we will be drawing very short lines. Hopefully, in this context, it will be good enough. If you're doing more fancy drawing, then it will not be good enough. But all right, we have a constant that is okay, I guess, right? Half was okay. I think that half was where it starts to get acceptable. Point 3 is also okay. I think I'm gonna go with 0.3. Yeah, I'm going to go with 0.3. Then let's do the quadratic. The formula is the same. That's all right. Oh, this formula involves a square root. This is not going to be happy. All right. So we learned that we like a new line there. We learned that we want 2 new arguments. And we learned that we want to change the body of the loop to do something that is just like this, I think. And then on the cubic, we want a new line there. We want these new arguments here. Oh, I forgot to bring in the color right before the body of the loop. And then this turns into that, and this turns into that. Okay, now let's experiment with drawing quadratic and cubic curves. We'll do okay, so we'll do linear in red, quadratic in green, and of course cubic in purple. And now we need to give the control points for this. The linear has 2 control points, the start and the end. The quadratic has 3 control points, the anchors in the beginning and the end, and an anchor point that both tangents are approximating to if you're interested in knowing what all of this is about, there is a stream in which we implemented this whole thing. So you can watch that. So this will do for my anchor point in the middle. Then the cubic has 4 control points. The 2 anchor points in the beginning and end, and then 2 other control points that control sort of like the bend of the curve. I'll put one there, and I'll put another one there. Oh, interesting. Was not expecting that. Let's take this step by step. What happens if I just have the linear? Not even the linear is working anymore. Okay, now the linear is working again. It's drawing in red. What if I bring back the quadratic? The quadratic is working, and it doesn't look smooth. 0.3 is not good enough. 0.5 will do. Okay. Now let's bring the cubic. Oh, and it works now. So I don't know why my screen turned orange before. Weird. All right, we have the 3 kinds of curves. They are working. They have support for thicknesses. So I'll call this done. Is it fast? Oh, apparently yes. I increased the step size, and now it is fast. I'm drawing more curves, and now it's holding 30 frames per second just fine. So you know what? Whatever happened before, it was either the waveform drawing that was taking the resources, or it was OBS, or it was something else in Reaper like my voice chain. I don't know. I don't care. I am taking off my list the idea of doing the GIFing, because drawing the waveform, the Bézier thing, without calling this function that is just implementing the formula from Wikipedia. I mean, imagine trying to get the GIF for this. Probably you could find it somewhere. I just won't. I will just continue using this because it's so simple and it performs well enough. The issue is somewhere else. In fact, if I have a step size of 1, is the performance still good? I didn't have the performance measurement before, and it's kind of sad that I'm doing red on red here, but it's holding 30 frames per second, trust me. If I just have a 1, does it look better? It looks better, yeah. And is the performance okay? The performance is okay. And if I go to like 0.8, I can see a difference, and it's not a good one. So you know what? The steps multiplier is going to be 1. Now it's mostly a matter of reformatting the code. Oh, hang on. Before I continue doing this, I will save, but then I will Command Z a bunch of times to bring back the multiplier, because now I'm interested in knowing what if the multiplier is greater than 1. Okay, we are back. I'm reloading the whole thing. Oh, and now it's orange again? What the hell? Okay. Let's see if I got everything right. If I do 0.1, it's not changing the appearance. Yeah, I'm doing something wrong. I forgot to Command Z some more, probably. May get a bit different, but smoother, I would not say that. Yeah, the difference between 0.8 and 1 is, yeah, it's something that I care about. It's visible. It gets better when it's higher. But going beyond that, not worth it. So now I'm going to Command Shift and Z to bring me back forward. And then I have removed all that multiplier stuff. And here I have removed the multiplier stuff as well. Now let's drop this on the track again. Yeah, and it's okay, it's fine. And it's holding up the frame rate just right. Perfect. I will cut and paste this here on top of my file, which is like a junk drawer of stuff, because eventually I may want to have a demonstration effect again. We had one before. And in that case, I will want to have these kinds of things. So I'm just dropping this here. There is also this showing how to do, I guess, transparency on this guy, this sort of thing. Right, so now we did thicker lines. We have a way of drawing thicker lines. Let's bring back the waveform. And now we need to do the drawing of the contours using the Bézier curves that we just re-implemented. Bo, I hope you appreciated this, because we sort of revisited the Bézier curves and it was not as trivial as cutting and pasting. So I hope you appreciated the ride. And the frame rate is being kept, so that's good. And we do have a stroke width going on here, so we would like to draw this stroke. Let's commit what we have before we continue. I guess this variable ordering, I mean, there's nothing in here. Here we removed this Bézier stuff, and here we added and modified. Great. This is the implementation of the waveform drawing. We have commented out the part where we do the drawing of the contour. Let's start with the rectified one, because we haven't done, I don't think, contours on rectified waveforms. Bo, you are so nice. For people who are not following the chat, Bo is being terribly nice to me. That's what's up. Okay, so let's start with the rectified waveform. So I will change this to be rectified. I have a drop-down menu for this now. So rectified true. And then I can see rectified waveforms. And as you can see, no contours. So let's do contours. I guess before I continue doing this, I do want to check something. We just brought in an implementation that comes from old code, and there is a chance that we leaked variables. There is a chance that the old code was doing something silly and leaking variables into the global context. And the way that we can check that, this leaking of variables into the global context is a sure way of introducing bugs. So the way we can check this is we can look for variables here. Local variables, remember that the underscore dot convention is only for global variables that our library introduces. Local variables, like parameters, local variables, they are all not namespaced, unspaced. So if you see any names here that you don't recognize in the effect, then it's a variable that is leaking into the global context. It's not happening. We only have channel that is there, and version that is here, and waveforms that is there. So that's all right. Our old code was good, and we didn't mess it up on the way. Next. How are we going to do the drawing of the lines on the rectified peaks? I do need to know the previous peak and the next peak in order to be able to draw. And I will say something that I don't think I said before, but I thought and I implemented, and I didn't really bring it out in my explanation. So let's go and do this. So in one previous implementation of the waveform display, I was doing the contours by simply looking at the peak that I want to draw. And then I draw, like in this case, a blue line that goes from up here down there, that sort of thing. So I would draw the blue line, and then I would draw a small rectangle here at the top. That does not work. And we saw it not working. I don't remember if I mentioned this, but I definitely didn't mention the solution. I just implemented the solution. So the problem is that if you just have a peak right here, but then there is like a big difference in volume from one peak to the next, there will be a square here, but there won't be a line connecting that square to the side. So sometimes we will need essentially vertical lines. For instance, here, we'll need a vertical line on the contour. So just drawing the top is not enough. So we did this in the past where we drew just the top, and that's not enough. So instead, I will need to draw lines, which is what this implementation that is commented out was doing. See, it's drawing lines. But to draw a line, I need to know not only the current peak, which is this position, I will also need to know the previous one. So I will have a variable for this for like the previous slice y. Yeah. I will create the variable here, and then I will remember to go up there and declare it as a local variable. Let me see. I guess I will check up here. So this is the loop where I'm doing the drawing of each one of those slices, as I'm calling them. So each one of these columns or each one of these pixels on the x-axis, they are called slices. So I am doing the slices on this while loop. I'm drawing each one of the slices. Before I do that, I will need to initialize things differently if I am on rectified or not. So if I am in the rectified peaks, I will have I guess that's what I am interested in. But I will call this the previous. That's what I'm interested in, the previous. Because I will want to change this so that I'm not doing rect. Oh, I will still be doing rect, but I would be doing something more. I will also be doing and it would be silly for me to do this if the stroke width is 0. So I will check if the stroke width is greater than 0, then draw. And what is the previous x? That is just my slice x minus 1. And what is my y? That is this guy. What is my current x? That's where I am right now. What is my current y? That's this variable. What's my color? That is my stroke color. Did I get it right? Stroke.color. Yes. Oh, and stroke alpha is not something that we support. And we don't support that because we are doing the drawing with a bunch of squares. So if you try to put an alpha on all the squares, they are going to... It's not the same as if the line was transparent. You are going to see the squares overlapping. So that's why I said that to do that right, you have to draw to an off-screen canvas and then bleach. Gets really complicated. So I don't think I will support stroke alpha. Which I will admit is not ideal. But perhaps this whole idea of the fuel alpha and the cursor alpha also don't make sense. I'm going to remove all of that because you might as well do the alpha on the whole waveform drawing. You may not want to have an alpha on the fill, an alpha on the contour, and an alpha on the cursor. You may just want to have the whole picture and then bleach the whole picture with an alpha. Yeah, that's what I'm gonna do. I will have a single alpha for the whole bleach. Let's look at all the places where I'm doing alpha stuff. And it will be this. It will be out of here, out of there, out of even the comment, out of there as well. And now I only have this alpha that I have to do right before I bleach. Oh, check this out. And that should do. Oh, I actually want to do... No, I'll do it like this. Yeah, I think that this will work. We'll see. And I need to change how this is called. And perhaps I shouldn't be calling it alpha. I should be calling it opacity. And then let's see, I have opacity in these two contexts. And if I just do that, I think it's fine. Okay, I think that if we solve this underscore situation, I think we'll have it. So let's see if we can do this. All we gotta do is perhaps this. Perhaps this will work. We'll take the read index, and in theory I should be subtracting one. Because I want the previous one. But in practice it may not matter. You may not even be able to see that. Then I will have to do this. If I am square rooting the thing. Well, I will have to sort of do this whole logic plus I will have to do some of the logic from here. So you know what? I think I'm going to do this differently. What I need is this variable. I'll start by saying that this is undefined. And then over here, I will check where am I going to check? I think I would check it over here. So if my previous is undefined, then my previous is equal to my current. And then naturally at the end, of the drawing, I will have to do that. Okay, I think that all of this makes sense. Then yeah, let's try this. And this is what it looks like. It is not drawing stuff on the contour, it doesn't seem. Let's revisit the function call. Well, first of all, let's see if there are variables that shouldn't be here. Oh, and there are. I forgot to... Yeah, stroke width is 0 because I am using the wrong name. It is stroke I removed more than I should have. Oh, stroke width was not even an option before. Stroke width and stroke color. And over here, I will do a stroke width of perhaps 2. Is that a thing? It is a thing. So now we have the stroke width variable to use. It needs 15 params. I didn't save this file, reload this file, full compile reset, and then we get orange again. Rectified. And we are drawing contours. Hooray! Do they look great? Are they the best contours ever? I don't think so. But they are okay. Perhaps it has to do with the little hack. Yeah, this is not good. Yeah, perhaps it has to do with that little hack. The hack being this. The issue is that it gets so complicated to compute the previous point. So how about we keep the previous point in the data structure? Yeah, that's what we did at some point. And for that, we need to be smarter about what we are going to store and where and how. Okay, I will commit what I have and then we'll try to come up with this fix. Over here, I just changed the arguments. We removed opacity. We added the stroke width. That's all fine. Over here, we did more stuff. We changed the argument similarly. And then we have this hack. At least this part is doing the right thing. I think I will add some new lines in there. Or perhaps not. The line is not too long. Okay. So now that we are adding this to the data structure, we need to know what we want to store. Over here, we'll have just the previous y, but over there on the non-rectified, we'll have more stuff. We'll have, I guess, the top and the bottom, essentially. Yeah, so I'll have two variables, two new variables. The previous top and the previous bottom. Image width, image height, right index, and then top, previous, bottom, previous. How about those names? How do they work? Let's see. We call this stuff the slice top and bottom. So I think I'll call this the slice top and bottom. Well, it has to do with the drawing of the image, not with the computation of the slice. So I will call it image top and no, it has to do with this slice. So I will call this slice top previous and bottom previous. These are elements 11 and 12. And now the whole data structure has 13, 0 to 12, 13 fields, and they need to be initialized. The previous top can be half of the height. Can be like this. So the previous top and bottom, right in the middle, where silence will be plotted. Then let's scroll down. We are going to remove a variable, a local variable. Oh, we forgot this local variable. We didn't declare it as a local variable. So it was actually leaking into the global context, whatever. It's no longer going to be undefined. There is always a definition of that. And we do need to get this though. So let's go and grab these two fields, put them right there. Into these two new local variables right after image right index, right there. And these are variables that are going to change. So I'm going in the end to write to them. Okay, now we have these variables in place. We need to use them. This is the hack. We can remove it. And then slice stop previews, slice, I'll use the top one. Top. Slice stop previews. Is the slice Y? Yeah, fair enough. Let's see if this works. Rectified peaks. And yes, we got rid of the glitches. There are no lines going down and poking in. I still don't love how it goes up and down like this, but I guess it's just the nature of the waveform that I have. I have a waveform that does that kind of spike. But it's looking good. Perhaps a stroke of even 2 is too much. Let's try a stroke width of 1, which you may think is 1 pixel. So I'm back to the line drawing situation, but actually no, because this is multiplied by X retina, which in my case is 2. So I'm actually getting a thickness of 2. And this is what it looks like. It looks pretty good. It looks okay. Very acceptable, I think. Yeah, okay, so next let's do the non-rectified version, which should be here. And the code for this will be pretty similar. So I'm going to copy and paste from there. Oh, I am setting this color. Yeah, that's how it needs to be done. So I'm setting the color for the field, and I draw the rectangle for the field, and then I have to do this. Parse is now going to be 2 parts. So I'll need parentheses and new lines. And over here, I will have top previews and bottom previews. This is going to be the top. And this is going to be the bottom. I can now get rid of all of this. Oh, check this out. I guess I had that name before, and I kind of like that name actually, because it's not It doesn't really matter too much. I'll just rename this because I think I prefer the other order. Now let's test this. And we do have a waveform drawing capability with the contours. And oh, interesting. See those little dots poking? That's not what it is supposed to do. It doesn't happen at the top. And that's why we didn't see it before, because it's not happening at the top. So it's not happening on the rectified peaks, but it's happening at the bottom. And we are drawing the more or less right location. So it's not that I have a variable that I messed up or something. This is probably some rounding error. What if I just take this and I just squish it up? Will it fill the gaps? Maybe. So I'm going to take the Y position and I'm going to subtract 1 stroke width of that to just squish that up. And now the little glitches are gone. I think we did it. Okay, I'm happy with this. Yikes. There are some poking. There are some. I can see when I zoom in, like there's one right here. There is that guy. I will not worry about that guy because when I'm zoomed out, I'm happy with what I see. Perhaps the stroke width is too much, or perhaps I chose a color that is too dark. I think I will try a lighter color. Perhaps the difference is just too big, from 500 to 700. What if I just put 600 in there? Is that better? Kinda. Yeah, I love this. It looks three-dimensional. It looks like there is light shining from the front, and then there is a bit of shade as the waveform goes. Perhaps this stroke width is not ideal still. Where do I define my stroke widths? Come on. There is no pixel stroke width. I think there should be. Yeah, there is a space pixel. Welcome back, Bo. So there should be a stroke width of pixel, which is just 1. And then border width of 1 pixel. That should be just 1. Now, it is ironic that I did all this work with the Bézier curves and everything so that I could have different stroke widths, and then I decide that the stroke width is going to be 1 pixel. But now it's possible. Let's look at this when it is just 1 pixel. Okay, this is what it looks like, and I actually prefer it with a single pixel. So there you go. That's what it is. But now you can have different stroke widths if you want. So it was not all for nothing. Let's see again what the rectified peaks look like. They look perfect. This is exactly what I wanted them to look like. So now I think I am ready to commit what I have, and we'll get out of here. So I added that. I'm happy with that. I added 2 fields. I remembered to increase the memory allocation. I put them to begin with in the middle. I added this as local variables. Do I have to change something about pushing? No. I added this as local variables. Did I forget any local variables? Let's do a full compile reset. A full compile reset is causing the orange thing. I am not too happy about this. It's probably because it's initializing some memory and then it's changing the meaning of that memory. I don't know. Anyway, let's scroll down and try to look at our variables. Okay, just the 3 of them. That was a kind of a hack. I'm happy to have gotten rid of that. Strictly speaking, I wouldn't need this if my stroke width is not... If my stroke width is 0, I wouldn't need this line because I don't need to keep updating the previous stop. But I think it's better to have the previous stop in there. It's just this that is expensive and silly if I am drawing a square of size 0. But this one is kind of cheap, so I don't have to guard against that. And then for this one, I just go and do the top and the bottom. Yep. And then I remember the top and the bottom for next time. All right. Bo is saying, can you have one shade on the top of the waveform and a darker one on the bottom of it? Yeah. I see what you mean. I see what you're going for. You're probably thinking of like there is a source of light above, so above you would pick a lighter color and below you would pick a darker color. We can. I don't think I will though, because I think it looks okay as it is and it would be more parameters for the user to pass, and the user here is the person using the library. But still, it's more parameters to pass. I think it's fine. Do you think it's essential to have different top and bottom? Because I don't think it's essential. But if we were to do that, we could by... What would we do to do that? We could even have different widths for top and bottom. But the way we would do that is just having two more of these arguments, or not two more of these arguments, and then there, right on this line, before we draw, we would... Oh no, we wouldn't do any changes before this line. We would just pass these other variables along. So yeah, it would be a matter of introducing two variables and using them here. I don't think I'm gonna do it though, because I think it's good as it is. Yeah. I don't know. I think that having even more arguments, when you want to draw the waveform, you already have to pass 15 arguments. I don't want to include two more. I think it's fine as it is. All right. So that was the contours. We did it. I think there was a to-do. Reintroduce the stroke with thicker lines. We did it. Next, a way to control whether or not the waveforms we set on playback start. That could be interesting. Zooming in. That could be interesting. It's more arguments. See? It's more arguments that we would have to introduce. And perhaps this would be another argument as well. Well. I think that all of this can wait. I'm not interested in zooming in. I'm not interested in a way to control whether the waveforms reset. So I'm going to do it. You waited for this for so long, months in progress, months of work. But I think I'm going to call the waveforms done. Yikes. This was a lot of work. Let's rejoice. This is working. How does this look? If it's rectified, if it's square rooted, if it is perhaps a bit smaller. What just happened? Oh, okay, it just wrapped around because I have a raise on wrap turned on. If I take this bit through, oh, this looks great. I love it when it's like small like this. Like in Ableton Live, there is this compressor that has a view just like this, and I think it scrolls even faster, and it's about this size, and it is great. I love the way that looks. So maybe we'll have something like this in our compressor someday. I mean, I also love the look of Pro C2 with its big waveforms, but it doesn't seem like JSFX loves this too much. It's junky when it's like that. And when it's small, it's much smoother. It's beautiful. So we'll see. Anyway, I am calling the waveform display done. Tomorrow, I will either be over at IDDQD Sound. Aria hasn't answered, so I don't know if we are going to stream together, or I will be here and we will be putting this waveform display to use on something. So it will either be that gain plugin that we started and it was using the waveform display there. We will either revisit that, or we will get to my auto mixer that I also want to have waveforms there. We'll do something with the waveform display because I'm calling it done. Iteration 1 of the waveform display is done. It's working. Or perhaps we'll just do a simple plugin that shows the waveform over here if you turn on the TCP embedding, or not the TCP embedding, the MCP embedding. Then having something like this properly packaged without the FPS thing and everything could be useful. If you have like a compressor in the middle, then you could have two of these guys and you could see the difference in the waveform or something. Could be useful. So maybe we'll do one of these. And then we could click and drag to zoom in, make the time that is covered slightly less, but zoom in, that sort of thing. And when effects are here, they are small, so they don't take as much resources. And check this out. They run at the frame rate of the DAW. They don't run at this frame rate. See? They run at the frame rate of the DAW, so they're much smoother, which is also nice. And we get this smoothness for free. And I think that the performance here, I didn't check this, but just by my experience and by eyeballing, it seems like the performance here is better than the performance when you ask for 60 frames per second there. Maybe just because this is bigger, I don't know. Anyway, see you tomorrow over at IDQD, maybe, or here to do something, some fun experiment with the waveform display. Thank you, Tail and Bo and Andres and everyone else. You are all great. Thanks to everyone who subscribes to the channel, who supports me on PayPal and Patreon, that sort of thing. And I see you tomorrow. Bye.
Thank you for watching the stream, you know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.